current carrying wire, a point is at some distance. Can you calculate magnetic field due to this wire at that point? Let's explore the law which helps us figure that out. Consider a conducting wire of an arbitrary shape, carrying a current I. One can consider the wire as made up of elements vector dl1, vector dl2, and so on to dln, each of an infinitesimally small length, so that each element is a segment of a line vector in the direction of the current. One of sector r of a point P with respect to this line element. The magnetic field vector dB at P due to the current I in the element vector dl can now be found by using Biot Savart'S law. The Biot Savart'S law. It states that the magnetic field produced by a current element I vector dl at a point with position vector r with respect to the current element is given by vector dB equals to mu 0 upon 4 pi I vector dl cross r cap upon r square. Here, I vector dl is the current element, that is, the product of the current I and the small length vector dl of the conductor, a vector quantity directed along the current. Mu 0 is the permeability of vacuum, that is equal to 4 pi into 10 to the power minus 7 Tesla meter per ampere. R cap is a unit vector in the direction of vector r. The direction of vector dB is that of the vector product of vector dl and vector r and is perpendicular to the plane formed by vector dl and vector r. The total strength of the magnetic field at P can now be obtained by finding the contributions by individual current elements and taking their vector sum. As the line elements are distributed continuously, the vector sum can be represented as line integral as vector B equals to integral of vector dB, that is equal to mu 0 I upon 4 pi into integral of vector dl cross r cap upon r square. Vector B equals to mu 0 I upon 4 pi into integral of vector dl cross vector r upon r cube. Note that the Biot Savart'S law is an inverse square law like the Coulomb's law. Using Coulomb's law, we can find the electric field at a point resulting from a distribution of charges. Similarly, using Biot Savart'S law, we can find the magnetic field at a point resulting from current distributions. Let's summarize. The Biot Savart'S law states that the magnetic field produced by a current element I vector dl at a point with position vector r with respect to the current element is given by vector dB equals to mu 0 upon 4 pi I vector dl cross r cap upon r square. The Biot Savart'S law is an inverse square law like Coulomb's law. A current-carrying coil produces a magnetic field around it. But how do we determine direction of that magnetic field around it? We will explore this in our upcoming videos.